We've become increasingly dependent on lithium-ion batteries since they were first commercialised 30 years ago. From our phones and computers to transportation and electrical grids that power our towns and cities. Not only does this mean that we will need to produce a lot more batteries to equal demand, we will need more sustainable systems in place to manage the amount of batteries in circulation. Researchers from across Imperial College London have been investigating how the sustainability of lithium-ion batteries can be maximised over their entire life cycle.
Researchers can often get very bogged down in the details, but sometimes it's good to look across the whole system and decide, well, actually, are we improving things or not? We work on techno-economic analysis, which means that you take a step back and you look at the whole system and across the whole life cycle of a product, and you assess the costs, the environmental impacts, and the overall sustainability of the product, as well as looking at its performance.
The transportation sector can play an important role in our transition away from fossil fuels. Internal combustion engines are responsible for almost a third of the UK's greenhouse gas emissions, and this can be dramatically reduced by moving instead to fully electrified vehicles.
So we're currently facing an energy transition away from fossil fuels, which are highly greenhouse gas emitting, towards renewable energies. For example, if we could make the electricity grid greener, we immediately also would reduce the environmental impact of lithium-ion batteries and EVs. Even though lithium-ion batteries are very important for us to move towards a green energy future, they also have a high environmental impact all along the battery lifetime or the battery value chain. And we want to make sure that we don't solve one problem by introducing new problems. So when we talk about battery sustainability, it's actually highly complex because you start from raw materials extraction, manufacturing, the use phase in an electric vehicle, and then also, of course, the end of life disposal.
With significantly more batteries being made, this could mean a looming mountain of discarded batteries once they come to the end of their lives. It is predicted that by the year 2030, 23 million electrical vehicles will be sold. This could result in 6 million tonnes of lithium-ion batteries reaching the end of their working lives by 2040.
At the end of the life cycle of the battery, when the battery no longer fits the bill, we need to decide what we do with that. If we simply throw them in landfills, we will end up with a battery mountain, which is a sad waste of materials, but is also potentially dangerous because lithium-ion batteries come with sort of certain hazards. So lithium-ion batteries, especially old degraded lithium-ion batteries, are more likely to suffer from thermal runaway. This means that if they are pierced or if they undergo or if they experience high temperatures, they might actually end up with chemical reactions which then ignite a fire. And so if these batteries are languishing in landfills, then that means that the whole landfill will set alight and produce more toxic emissions.
At Imperial College London, researchers are looking at how we can make batteries more sustainable. This includes using renewable energy to make and recycle batteries, sourcing materials that have a reduced environmental footprint, either through recycling or cleaner mining practices, making more energy-dense and longer-lasting batteries, and designing batteries that are easier to recycle.
So there are three principles in extending the life of any product, and that is reduce, reuse, recycle. So reduce would obviously be that we use fewer batteries, but unfortunately with the transition to the green technologies, we need to use more batteries, so we can't really do that. But we can reuse them.
So the recycling processes of batteries is highly important, especially when we talk about the critical materials beforehand, like lithium and cobalt. So we want to make sure that we can recover those materials and not lose them in batteries disposed in landfills. However, recycling processes are still quite complex, especially also because the battery chemistries are quite different.
If they had nice clear labels attached to them, that would be a very simple way that will make them more recyclable, because then recycling companies would be able to sort them easily and decide which processes to apply to each one.
The Energy Futures Lab and the Institute for Molecular Science and Engineering have brought together expertise from across Imperial College London to investigate the sustainability of lithium-ion batteries. Together, we have shown that by improving lifetime, energy density, and recycling of lithium-ion batteries, we can make them more sustainable. Read our briefing paper to find out more.